SD 5,5. Engineers of Heinrich Wagner Sinto travelled to Italy to visit Veco, a well-known foundry. The reason for this trip is that we were privileged to deliver a highly modern ZFA SD 5,5 green sand moulding plant to the foundry. But what kind of plant is actually concealed behind this cone? Spare us a moment and we'd be delighted to show you what this highly innovative plant can really perform. Actually, we could start at any point in the plant cycle and follow the production flow. But the best place to start is where the empty moulding boxes arrive, after shakeout. Pallet bogies transport the empty moulding boxes to the moulding line. This section of the line is where the boxes are fed to a dual lift and separating station. The process starts with the moulding boxes being separated. At the same time, the drag and cope are lifted to the feed level of the moulding line. At the start of the moulding line, any residual sand is removed from the interior of both drag and cope by spring-mounted shapers. This is followed by a combined scraper brush unit that cleans the outside contours. A control unit monitors the conveyor and surfaces constantly, ensuring smooth operation. If any residuals are detected, the line stops immediately. And this is the heart of the plant, the moulding machine. Both drag and cope are produced in a single process. Moulding is done by the world-famous shiatsu process. As soon as the two moulding box halves arrive at the machine, the lifting tables travel upwards, lifting the pattern bolsters with the patterns under the moulding boxes. Simultaneously, the sand filling frames are taken up. On the way up, a blow-off system blows the spilled sand away from the pattern plates at a low noise level. Before we follow the moulding process any further, let's take another look at the rotating platform containing the patterns on pattern bolsters. Changing patterns is as easy as this. And the production cycle can begin. The required amount of sand is pre-weighed and distributed into two hoppers. Subsequently, it's filled into both moulding box halves. Before the sand is filled in, a spraying device coats the patterns with separating solution. After the sand is filled in, the squeeze heads shuttle in for compaction. The lifting cylinder presses the sand filling frame up against it, hermetically sealing the entire moulding box. A short, strong airflow completes the pre-compaction of the sand. The immense pressure of the hydraulic multi-ram press gives the mould its ultimate strength and stability. The patterns are then lowered out of the moulds. And a new cycle can begin. Let's follow the perfectly moulded boxes on their way through the plant. This dual turnover unit rotates each pair of moulding boxes through 180 degrees. The moulding plant operates at a rate of 200 moulds per hour. This results in a cycle time of 18 seconds. There are 250 moulding boxes in circulation at any one given time. The rows of boxes and pallet bogies are indexed using hydraulic cylinders, ensuring collision-free acceleration and slowdown. Here, the copes are transferred and set on a parallel conveyor line. The emptied and cleaned pallet bogies are transported to the core setting line under the cope transfer unit by a transfer truck in reverse motion to the drag transfer unit. From here, you can see the mould boxes moving in different directions quite clearly. On the left, the drag. In the centre, the cope. And on the right, the moulds emerging from the cooling tunnel. We'll deal with it later. Let's take another look at the cope conveyor line. The centre section. If required, this section can also be used to place cores in copes. And at the end, as you see, a turnover that rotates the copes back so that the mould surfaces face downwards once again for closing operation. Underneath this cope conveyor line, a number of important units are installed. This conical drill, for instance. This is the tool used for precisely cutting the sprue. Once the moulding boxes have been rotated, you can see how precisely they've been drilled. After sprue cutting, a venting unit with mandrel opens several pre-formed vent holes. Sprue cutter and venting unit with their coordinate shifting mechanism can be located precisely in any position below the mould. Let's turn our attention to the drags. The moulding boxes on the pallet bogies are transported through the core setting section on tracks. There are 8 open drags ready for use in this section. The current job only requires quite small cores, and these can be set manually. Hoists are installed for the larger, heavier cores. The engineers at HWS who designed the plant have not only developed a technically perfect concept, but have retained the human operational aspect as the focal point of their design at all times. This is demonstrated, for instance, by the ergonomic design of the core setting section, which allows the operators to work with minimum fatigue. This scene shows the closing station with peripheral installations. As we mentioned earlier, this includes the turnover for the copes and the transfer unit for the drags. Unlike the dual turnover unit at the end of the moulding machine, this unit rotates only one box each time. The drag transfer trucks convey the drags to a lift station halfway along the transverse transport stretch and then return. A second transfer truck approaches from the opposite direction, and the boxes are placed onto it and taken to their final position. Then comes the closing station. The cope is lowered onto the drag. And the mould is closed. In the same cycle, the 2 moulding box halves are securely clamped together. Unfortunately, we can't see the clamping procedure from this angle. The process might sound complicated, but the whole thing is really quite simple. Let's watch one more cycle. Next stop, the pouring section. In keeping with this plant's high output, it's equipped with a fully automatic pouring unit. The metal to be poured is transported from a furnace in an adjacent hall. The complete moulds run through the pouring section. Everything operates automatically and is electronically controlled. The design of the plant allows manual pouring as well. The poured moulds are then taken by transport truck out of the pouring section and indexed into the cooling section. The moulding boxes remain on the pallet bogies that have already transported the drags to the core settings section. So what happens next? Watch the transport track on the right. Over there, the moulding boxes that have just come from the pouring section are pushed into the cooling tunnel. On its way back, The transfer truck brings a cooled moulding box out of the tunnel. There it comes now. The cooling tunnel is designed to operate over 4 levels. Only 2 of these are currently in operation. Cooling time is 60 minutes. The cooling time can be extended to 112 minutes if the tunnel is used to full capacity. A cleverly designed lift and conveyor system does all the stacking inside this section of the plant. The moulding boxes emerging from the cooling tunnel are now transported to the punch-out station. There are 2 sand parcel punch-out units, 1 shuttle carriage and 2 accompanying lifting units. It's pretty obvious that with all the steam and dust here, as well as the machine's housing, a good shot of the scene is out of the question. So we'll show you an animation of the punch-out area to illustrate the process in a simplified schematic form. In this process, the moulding boxes are lifted off the pallet bogies and alternately transported to one of the sand parcel punch-out units. Meanwhile, the emptied moulding box is returned and placed on a pallet bogie. Punch-out is done upwards, and the sand parcels are pushed into a transport channel. Now we continue towards the shakeout grid onto which the sand parcels finally fall. The vibrations separate castings and sand completely. Any lumps of sand left disintegrate during transport and fall down onto a used sand conveyor belt. What you're left with is top quality moulded parts. The process has now completed a full cycle. The moulding boxes leave the punch-out station and are transported to the separating station. In fact, right where our film started. And adjacent to it, the used sand is taken away to the sand plant for reconditioning. So now you know about the technical side of things. But what is it which guarantees the smooth interlinking of the countless individual elements that make up the entire plant? Our superb electronics and electrical systems. A high-performance plant like this one here at Veco has to have a suitably powerful and efficient hydraulic station. And this is it. Before we end this little film, we'd like to show you the moulding plant with different castings. As you can see from the models, moulds can be made that need bigger cores than we've just seen here. Although the men handle the cores as though they were bits of polystyrene, they're about as heavy as anyone can deal with manually. With so many cores in circulation, the cycle time of the plant is determined by the core setters. To sum it up, here at Veco, we've put together a plant that allows the entire production spectrum to be covered rationally and to the highest possible standard of quality. Another aspect, of course, is the plant's environmentally friendly operation. After all, it's located in Martinsicuro, directly on the Adriatic Sea, and right in the heart of Italy's tourist area. Heinrich Wagner Sinto. We design, manufacture and deliver moulding plants that meet the needs of today and tomorrow.